All right, write the electron configuration for aluminum. All right, so you need to know how many electrons are in aluminum. Look at the periodic table. You can see that its atomic number is 13. It has 13 protons and it has 13 electrons. So you want to say where those 13 electrons exist. You know that they are in the lowest subshells first. So there will be 2 in the 1s, and then 2 more in the 2s. And then, let's see, so at this point we've filled up to 4. We get a total of 13, so fill the 2p. How many do we have now? So 4 plus these 6, that's 10. But we get 13, so next 2 will go into the 3s. That's now we're at a point of having 12. We have 1 more electron. It'll go into the 3p. And so we'll write the electron configuration is, let's see, 1s2. There's 2 electrons in the 1s. Then 2s2. There's 2 electrons in the 2s. 2p6. 6 electrons in the 2p. 3s2. 2 electrons in the 3s. And then finally, 3p1. And that gives us a total of 2, 4, 10, 12, 13 electrons. This is the correct electron configuration. Now, on the test, you will not have this whole diagram written out for you. So you'll need to remember which orbitals to fill first, and well, which subshells to fill first, and how many orbitals are within those subshells. And remember how many electrons you can fit into those subshells, therefore. So you'll need to remember all this. One nice trick to remember all this is to use what's in orange here. Use this diagram. You will probably want to write this out immediately when the test is given to you. So this tells you what what orbitals exist, which ones are filled first, and then how many electrons can go into the subshells there. So you can see in these purple arrows the order in which we'll fill subshells. Fill the 1s first, then fill the 2s, then the 2p, then the 3s, then the 3p, then the 4s, then the 3d, 4p, 5s, 4d, 5p, 6s, etc. Okay, so let us use this now to write the electron configuration for aluminum. You see, right above all this, I've written how many orbitals are within each subshell, and then therefore how many electrons can go into it. Now, S subshells have 1 orbital within them, or you can fit up to 2 electrons in S subshells. P subshells, they have 3 orbitals within them. You can fit up to 6 electrons in P subshells. D subshells have 5 orbitals within them, and you can fit 10 electrons within them. F orbitals, subshells, you can fit 7 orbitals within them, and therefore 14 electrons. Okay, so considering all those, let's fill out the 1s first. So 1s, and then we know we can put up to 2 electrons in there. Okay, so 2 electrons go into 1s. Then after the 1s, we fill the 2s. So 2s, we can fill that with up to 2 electrons. Then we fill the 2p. That can hold up to 6 electrons. Let's see, how many electrons do we have here so far? 2 plus 2 plus 6, that's 10. So we get 3 more. So after the 3p, we'll fill the 4s. That can hold up to 2 electrons, 4s2. And then we'll fill the 3, whoa, what's going on here? I've made a mistake. After the 2p, we fill the 3s, not 4s, 3s, my bad. So the 3s2. And then after the 3s2, we'll fill the 3p. But how many electrons can we fit in there? We only get a total of 13, but right now we have 2, 4, plus 6 is 10, plus 2 is 12. Right now we have a total of 12 electrons. We have 13 that we can write in here, so we get to write 1 more. Okay, so this is the electron configuration for aluminum. Let's try something more complicated. Let's try, how about bromine? Okay, bromine. Now bromine has an electron configuration, oh actually how many electrons does it have? On the periodic table, its atomic number is 35. So we get to write up to 35 electrons. So we could do it by this method, where, please note, very strangely, after you fill the 3p, you'll be filling the 4s, and then the 3d, strange, and then the 4p. But how many should we plug into here? We get a total of 35. How many do we have here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 33, 34, and then a total of 35. This is the electron configuration in the diagram, or to write all this out, it's, wow, 1s2, okay, so the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, finally 4p5. Wow. And just to check our answer, count the total number of electrons here. 2, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 5 is 35. Perfect, we should have 35 electrons. Okay, but again, we don't get this diagram on the test. We need to write out this orange part on the test. So writing all this out and following it, we go, let's see, 2 electrons can go in the 1s, then we'll fill the 2s, 2 electrons go in there, 2s2, then the 2p, we can put up to 6 electrons in there, 2p6, then the 3s, we can put 2 electrons in there, 3p, we can put up to 6 electrons in there. How many do we have so far? 2, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. But we get to have 35. So keep on filling. So fill the 4s, so 4s2. Then fill the 3d. 3d, oh, how many electrons go into the 3d? We can put up to 10 electrons in 3d, so 3d 10. And then, let's see, 4p, oh, how many do we have so far? 2, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30. We have 30 so far, but we only got 35. Normally we might fill in 6 here, because we can fill up to 6 electrons in the 4p subshell, but we don't have enough electrons to fit in there. Actually, we only have 5 left, so we'll write 4p5. This is the electron configuration for bromine. All right, thanks for watching. Oh, actually, I also want to talk about, we've mentioned how many orbitals are in the S subshell, P subshell, D subshell, F subshell, and therefore the number of electrons that can fit into those. But on our test, you may also have to say how many subshells are within principal energy levels. So within principal energy level 1, n is equal to 1, there's 1 subshell. Within principal energy level 2, there's 2 subshells. Within principal energy level 3, there's 3s, 3p, 3d, 3 subshells. Within principal energy level 4, there are 1, 2, 3, 4, 4s, 4p, 4d, 4f, 4 subshells. That's very interesting. For the first 4 principal energy levels, there are as many subshells as the principal energy level. Principal energy level 1, 1 subshell. Principal energy level 2, 2 subshells. 3, 3 subshells. 4, 4 subshells. Now, you may also have to say how many orbitals are within a principal energy level. In principal energy level 1, there's just the 1s that has 1 orbital within it, so there's a maximum of 1 orbital, or 2 electrons that can fit into principal energy level 1. In principal energy level 2, there are these 2 subshells. There's the 2s and the 2p. The 2s takes a total of 1 orbital, and 2p takes 3, so 1 plus 3. 4 total orbitals go within principal energy level 2, and how many electrons? Well, 4 orbitals, you can fit twice as many electrons as orbitals, because you can fit 2 electrons per orbital. So 4 times 2 is 8. Or another way to say it was 2 plus 6 total electrons, so 8 total electrons go into principal energy level 2, etc., etc., etc. All right, thanks for watching, guys.